Okay, one last video about logs, and now we get to the last sort of topic or kind of problem. And that's when you're trying to solve an equation with multiple log terms. In a minute, we'll solve this is log base 6 of x plus 6 equals 1 minus log base 6 of 2. I want to solve for x. Because I got three terms here. This term's just a number. These other two terms are log terms. How do I go about solving an equation like this? Let me briefly outline the steps that I'm going to follow to solve these kinds of equations, and then we'll simply do 4 or 5 examples. First thing I do is I say get all the log terms on one side, and if there are any numbers, obviously get them on the other side. So get all the log terms by themselves on one side. And then once you do that, combine all log terms into one log term. So you may have 2 or 3 log terms now on one side. Well, using the rules we just talked about, combine those into one log term. So after step 2, your equation should be one log term on one side and a number on the other side. I'm just making this up. Maybe it's log 4 of x minus 2 equals 4. So since it looks like that, I'm now going to take this equation with a log term and convert it into an exponential equation. We've already done that before. In a minute, you'll see me do it again. Let me just finish out these steps and we can actually do some problems. And you're going to see, after we convert this into an exponential equation, I'll be able to solve it. And then the last step, which is not optional, you need to go back and now check each of your solutions. Now you don't really have to necessarily plug in each solution and redo the whole equation. The key thing is what can happen is some of your solutions, if it causes you to end up with a negative number inside the long term, you can't have that. So if any solutions end up giving you a negative number inside the log term, then that is not a solution. So as I work through some examples, as I work through some equations, we'll see if this occurs. All right, we'll go from equations, hopefully not too difficult, to maybe a little more challenging. Pretty straightforward equation. Log, what's the base here? Base is 10, right? So log base 10, or common log of x plus 6 equals 1. Solve for x. This first example is actually only one log term, and it's already by itself. So really, first two steps I can sort of skip. So I'm now at the point where it says, now convert it into an exponential equation. Circle method, right? Ten to the first equals x plus 6. Pretty easy. And now you look, solve this equation. Very simple equation to solve. X equals 4. However, don't forget, you got to check your solution. And I plug in 4 in for x. This becomes log of 10. It's okay. Not too hard. Let's do some more. Log base 4 of x plus 2 equal log base 4 of 8. Now as you look at this problem, as in most of math, there are other ways to solve it besides what I'm going to do. But just so you know, I'm trying to, just to make it simple, follow these steps. Because these steps can be used for any equation with log terms. There are always special equations, you can sort of use shortcuts, but just to make it simple, I'm using the same method. So here I have two log terms and that's all. I want to get them on one side, so let's go ahead and we'll subtract log base 4 of 8. The next step says, now take all your log terms and combine them into one log. Now, since we're subtracting, first of all, the rule is same base, no coefficients, we're good there. Now, since we're subtracting, it ends up being x plus 2 over 8. Now the next step, convert this into an exponential equation. Use the circle method, right? 4 to the 0 equals x plus 2 over 8. What is 4 to the 0? That's just 1. If I solve this, multiply both sides by 8, subtract 2 from both sides, I'm saying the solution is x equals 6. If I check, if I go plug it back in to my original equation, plug in 6 here, you get log base 4 of 8, which is okay. There's my solution. Not too hard. All right, let's go back to the one example I gave you at the beginning. And that was log base 6 of x plus 6 equals 1 minus log base 6 of 2. It's like I got 3 terms here, 2 log terms and then a number. I want to get the log terms on the same side, so I'm going to add log base 6 of 2 to both sides. Now I'm going to combine the log terms into one log. So same base, no coefficients. Since I'm adding them, when I combine them, I'm going to end up multiplying them. So this really becomes, if I multiply out the parentheses, now I want to go ahead and convert this into an exponential equation. Six to the first equals 2x plus 12. If I subtract 12 from both sides, divide both sides by 2. So I'm saying the solution is x equals minus 3. However, let's go see if it's okay. If I plug in minus 3 for x in the original equation, this ends up being log base 6 of 3, which is okay. So it looks like it checks out. All right. Let's get one more, maybe a little more involved than the one so far. We'll do a natural log problem. All the same steps and rules apply. So natural log of x equals natural log of x plus 6 minus natural log of x minus 4. Looks like I got a problem of 3 natural logs. First step is to get all the logs on one side. I'll subtract natural log. Oh no. Let's do this. Let's move everything to the left-hand side. I'll have 2 positive terms and 1 negative term. So I have to add natural log of x minus 4 to both sides. Then I have to subtract the natural log of x plus 6. So I got 3 natural log terms. If I would combine them into one log term, same base, no coefficients. The key is the positive terms go on the top of the fraction, the negative ones go on the bottom. So it's going to be x times x minus 4 over if I multiply out the parentheses, x squared minus 4x over x plus 6. So now I have one log term equals a number. I'm going to convert this into an exponential equation. Circle method, right? What's the base here? Actually e to the 0 equals everything inside the log. What's e to the 0? It's 1. Now to solve this, let's get rid of the fractions. Multiply both sides by x plus 6. X plus 6 equals x squared minus 4x. This looks like a quadratic equation. Let's get everything on the right-hand side to solve it. So I'm going to subtract x from both sides, which leaves a negative 5x. Then subtract 6 from both sides. Now to solve this, I'm hoping it factors. If it does, So my product is -6, my sum is -5. I think hopefully that's correct, which I believe it is. So then I actually have two solutions, 6 and -1. All right, that was a lot of work, but we've solved it. However, we're not done. I have to check each of these solutions. So let's just take x equals 6, and let's go plug it back in the original equation. If I put the 6 in here, I'm okay. 6 in here, I'm okay. 6 in here, I'm okay. That one checks out. Let's see what happens when I plug in -1. And right away, hopefully you can see, I would have natural log of -1. I can't have that. We cannot take logs of negative numbers. So even though the math gave me this solution, when you go check it, it's actually not a solution. So there's really only one solution, x equals 6. Now let me, as a final wrap up, so that's examples of solving equations with multiple log terms. As just a final wrap up, because I think some of these are in the homework, let me do just a couple more solving exponential equations. Hopefully nothing I'm doing here is new. Now my suggestion is when you're solving these kinds of problems, it's been so long you might have forgotten it. Here's an example. You could take the log of both sides and you could solve it and that would work. However, don't forget the very first thing that we talked about in solving exponential equations. If you can somehow get the same base on both sides, then that makes the problem really easy to solve. So we've been doing logs so much, maybe you see this and you want to just dive in and take the log of both sides, and that would work. But the other option is, it's a lot simpler if you do this. And there's your solution. Now you would have gotten the same solution if you took the log of both sides, but all right, this one looks sort of ugly. 8 to the negative x equals 1.2. Trying to solve for x. Let's just take the log of both sides and see what happens. Inside here, this whole exponent can go out front. If I solve for x, I'll divide both sides by log 8. Multiply both sides by -1. If they want an exact answer, I would stop, but sometimes I may ask to give the answer rounded to, say, 2 decimal places. So then you go grab your calculator. Log of 1.2 divided by log of 8, and then make it negative. Maybe I'll go to 3 or 4 digits just for fun. 0, 8, 7, 7. And just to see if this works, if I plug this in up here, So if x is negative this, 8 to the negative x means 8 to the point 0. If I did this problem correctly, this is what I'm saying. I can actually calculate this using my calculator. So for me, I enter 8. So you see, for this one, I enter 8. And then for me, it's a y to the x key, which allows me to set my exponent to 0.0877. What does that equal? 1.200005. So, yep. That's it. Now this last one, which I'll go ahead and do it, this is a fair amount of, this one gets a little messy. It's got a lot of algebra to it, but let's go and do it as the final problem. 5 to the x minus 2 equals 3. Two exponential terms on each side, both with x in the exponent, although actually different bases. I got a 5 here and a 3 here. The only way we can hope to solve this is to take the log of both sides. Now I'm going to use common log, log base 10. You could use natural log if you want, because we're going to actually calculate a number, use our calculator. So I want either common log or natural log. I'll do common log. So for both of these, let's take the exponent inside the log and move it down in front of the log. Now if I'm going to solve for x, I'm going to have to multiply out these parentheses and then get every term with an x on one side and every term without an x on the other side. So if I distribute the log 5, it's x log 5 minus 2 log 5. Now if I distribute the log 3, 3x times log 3 plus 2 times log 3. So I've got 4 terms here. You notice these 2 terms have an x. These do not. Let's get all the terms with an x on the left-hand side. If there's not an x, move it to the right-hand side. So x log 5 minus 3x log 3 equals 2 log 3 plus 2 log 5. I'm going to now factor out this x over here. So I get log 5 minus 3 log 3 equals 2 log 3 plus 2 log 5. Now to solve for x, divide both sides by this whole parenthesis. 2 log 3 plus 2 log 5 over log 5 minus 3 log 3. That would be the exact solution, because everything on the right hand side is just a number. Now if they want an actual decimal number, then if you have fancy calculators, this isn't too hard with my calculator, it's a little more work. Matter of fact, I'm going to first calculate the denominator. So I'm going to do this first. I'm going to do log of 3 times 3 equals, make it negative, and add to it log of 5 I actually do have in my calculator the ability to save this number, so I don't have to punch it in by hand. I'm going to go do the top now, so I'll just start over here. Log 3 times 2 actually, let me do this differently. I'm going to factor out this 2. So really, I'm going to do log 3 plus log 5 equals times 2. So hopefully I've done this correctly. 2.35218. So that divided by this, negative 3.21. Just for fun, let's see if it's correct. So I have 5 to the negative 3.21 minus 2. So I'm plugging x back into my original equation and see if this works. 3 times 3 times negative 3.21 boy, this is ugly. Let's see what this thing equals first. This is going to be negative 5.21. So 5 to the 5.21 negative this, I have to take 3.21 negative times 3 equals plus 2 equals, so negative 7.63. So 3 to the 7.63 negative, and looks like I must have been careful with my math. It looks like it is correct. So that must be the solution. All right, that was a lot of algebra. Basically, logs, once again, gives us a way to solve equations with exponential functions. All right, so hopefully, as you work through your problems, you realize these logs are not that hard once you sort of get the feel for it and learn the rules.